Hello there, Algebra 2. We're ready today to take a look at the parent function absolute value. Now we had talked about the parent and the transformations before, and so this is the one first one we're going to look at in depth as far as an algebraic equation and its graphs. And so follow along. I know you can do this, and we're going to get through this and manage to get the test taken before the gentlemen go away on their trip. And so let's just take a look at what we've got. So if you remember, the absolute value of x means that you're going to be taking whatever number it is and finding out how many units away from 0 it is. So when we look at this parent function, y equals the absolute value of x, I want to make a table of values to see what that's going to look like. I'm going to choose 0, 1, 2, -1, and -2 as some values that I want to plug in for x to find out what y goes with them. So this goes way back to pre-algebra when we were trying to make graphs of lines. So we'll plug in a 0. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of -1 is also 1. The absolute value of -2 is 2. So what we've done is we have our x values and the y's that go with them in our parent function. I want you to take your graph and I want you to make a graph of those ordered pairs. Okay, so you take your graph, we're going to take 0, 0, we're going to take 1, 1, we're going to take 2, 2, and then over here at -1, it doesn't keep going down here, it turns around and it starts going back up like this. We can imagine that if you put in a 3, you get 3. If you put in a 4, you get 4, and it would continue in that same pattern. Goes on forever. In this case, it ends right here. It does not keep on going. It's not a line. It is an absolute value function. All of the absolute value functions have this V shape happening. Okay. We can look at some other ones. Okay, if this is the parent, you might already have an expectation of what this -3 is going to do. F of x was the absolute value of x, then we take 3 away from the whole thing. Your expectation should be that it moves down 3 units from the original one, but let's plug in some values just to find out what they turn out to be. So when I plug in a 0, the absolute value of 0 is 0 minus 3 is -3. So this will be -3. I know that it doesn't let me write very nicely on top, so I have to do it as a reveal here. Okay, here we go. The absolute value of 0 minus 3, the 0 minus 3, which gives you -3. The absolute value of 1, 1 minus 3 is -2. Absolute value of 2, 2 minus 3 is -1. Absolute value of -1, 1 minus 3 is also -2. And the absolute value of -2, 2 minus 3 is -1. So once again, we can put these into your graph. Make your graph 0, -3, 1, -2, 2, -1, -1, -2, -2, -1. Connect the dots. You see that same V shape, but it's moved down 1, 2, 3 units from where it was. So our transformations, we're using this absolute value function to show that the transformations we talked about before actually work, and also kind of get the idea that we're going to be doing this all year long with different functions and then moving them around by transforming them. But we don't always have to do the table of ordered pairs because we know what we're expecting to see. Once you have the parent, you're just going to be moving it around based on the patterns. Okay, whoops. Let's take a look at this one, the absolute value of x minus 3. This is the one where if you had like f of x minus 3, so what we're expecting here is that it's going to move to the right 3 units. I'm going to change my x values to show you how that works. But remember, you're not going to end up plugging in always. Okay, I'm going to choose my first x value as being 3 this time. Okay, because I know that when I plug a 3 in here, I'm going to get 0, and that's going to be important. And I'm going to choose a 4 and a 5. You're not necessarily going to have to do much of this choosing on your own if you can recognize the pattern. Okay, so 4, I plug in a 4. 4 minus 3, I get a 1. 5 minus 3, I get a 2. I also need the other side of it though. So I need to choose a couple of values smaller than the 3. So I go the other direction. When I put in 2, 2 minus 3 is negative 1. The absolute value is 1. If I go even lower down to a 1, I plug in 1 minus 3 and I get absolute value and I get a 2. So we still have our V, but when we draw our V, you have 3, 0, 4, 1, 5, 2, and then 2, 1, and 1, 2. So you end up with this nice V shape that is moved 3 units to the right, just like we talked about with our mystery figure that I was moving around on the graph. So we've got the V here, back here. Okay, this one moved down 3. This one moved right 3. What can also happen is you can have a combination of things happening. This one has something happening inside here and outside here. This one inside, our expectation is going to be that it moves 3 left. This one is going to be expecting it to move 2 down. So I'm going to choose some values here. I'm going to choose to start with a negative 3. That's going to give us a 0 in here. That will be helpful. So when I choose that negative 3, and I plug that in, that's actually going to give me the corner of my V, and it's going to be nice. So I plug that in, and I put in negative 3 plus 3 gives me 0. 0 minus 2 is negative 2. I want to choose 2 values above and 2 values below the negative 3. So I'll put in a negative 2. Negative 2 plus 3 is 1. 1 minus 2. We'll see one thing at a time. 1 minus 2 is negative 1. I'm going to next pick, just for us to see, if I put in a negative 1, what I find is negative 1 plus 3 gives me 2. 2 minus 2 gives me 0. Okay, so I've gone one direction on my V. To get the other direction on the V, I'm going to go the other way from negative 3 and go down to negative 4. Negative 4 plus 3 would be the absolute value of negative 1, which is 1. 1 minus 2 will give you negative 2 again. Sorry, 1 minus 2 would give you -1, I'm sorry. Absolute value of -4 plus 3 is the absolute value of -1, which is 1. 1 minus 2 is -1. Notice our pattern is repeating. When I plug in a -5, -5 plus 3, -2. That gives me 2 minus 2, which is 0. All of these values here can then be placed on a graph. -3, -2, -2, -1, -1, 0, -4, -1, -5, 0. And what we notice is that this went left 3 and down 2 from the anchor point at the origin, but the whole picture did the same thing. It was that same V shape, okay? So the things inside here are going to tell you left or right. The things out here are going to tell you up or down. If you have a number right here, that's going to tell you if you have a stretch or a compression. Since this number is bigger than 1, you're going to think it's going to stretch 2 units, okay? So we're going to see what happens when we plug in 0 and 1 and 2 and -1 and 2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 1 is 2. I'm doing the absolute value. 2 times 2 is 4. Notice that these values are double the values we got with our very beginning one that we did. So when we graph them, it's no longer just going up like this, it's now stretched as if you took your hands and you pulled these pieces upwards. It's a stretch of 2. Okay. Remember I told you the other day, I told you yesterday, when you have a fraction that's smaller than 1, we're going to end up with a compression. It's going to smush it down. So I'm going to plug these in. We also have this negative, so we'll see what that does. When I plug in a 0, I get 0. When I plug in a 1, I get -1/4. When I plug in a 2, -1/4 times 2 is -1/2. I want to keep going until I get an integer because it's way easier to graph integers. 3 is not going to give us an integer, but 4 will. When I plug in a 4, I get -1 here. Okay. Oops. And I'm just going to choose those values for you so you can see what's happening. When I do a -1, I still get a -1/4. When I choose a -2, I still get a -1/2. So my negatives are giving me the same values as my positives did because we did absolute value on it. When I graph it though, here's what happens. 0, 0, 4, -1, -4, -1. These little half points, here's my quarter, here's my half, here's my quarter, here's my half. I'm getting a V, but it's really smushed down as if somebody stepped on it, and this negative made it flip upside down. So that goes right along with what we were talking about with the parent functions and the transformations. So that is what's happening with those. We need to continue on with that idea and think about the corners of the V. The corners of the V are going to give us what's called the vertex. It will be a maximum or a minimum. It's a maximum if it's the top of the mountain. It would be the maximum. if it looks like a regular traditional V, it'll be a valley, which will make it a minimum. So it will be you go down the valley and get to the minimum, the smallest place, or you go up the mountain and you get to the maximum, where the vertex lives. An axis of symmetry, if you remember from geometry, if you had a symmetric situation, you would have the same thing on the right as you had on the left, and you could fold it down the middle and get the same figure. So on these graphs, okay, we looked at all these graphs a minute ago, so here they all are. What we can do is we can identify where the vertex is and where the axis of symmetry is. The vertex is just the ordered pair at the corner of the V. So our vertex here is 0, 0. Our vertex here is 0, negative 3. Our vertex here is 3, 0. Our vertex here is negative 3, negative 2. Our vertex here and our vertex here. Hopefully you answered them yourself in your head. Write them down, please. Those are your ordered pairs that go with your vertices. Axis of symmetry is that invisible line that goes through the vertex. So here it is, all these little dashed lines that go down through. These are your axis of symmetry for each one of them. There's an equation for the axis of symmetry. You may remember or may not remember that a vertical line has an equation of x equals a number. So all of these axes of symmetry have to have x equals whatever number that goes in there. So my axis of symmetry here is where x equals 0. You can pull it right out of the x coordinate on the vertex. So x equals 0 is this axis of symmetry. I know you can see them all. There we go. On this one, the x coordinate is 0 and the vertical line goes through 0. So my axis of symmetry is where x equals 0. Has to have the x equals because the symmetry axis is the entire line. This axis of symmetry is where x equals 3. This axis of symmetry is where x equals negative 3. Here, it's where x equals 0. And here, it's where x equals 0. Okay, so I've talked about your transformations, your left, your right, your up, your down, your axis of symmetry, your vertex, your stretch compression. We have an absolute value function. It will be in this form. You have a number times x minus a number plus a number. Your vertex will always be whatever this number is, comma, whatever this number is. So you don't have to graph it to tell what they are. X equals this number is our axis of symmetry. If this number is greater than 1, it will be a stretch. If this number is, there isn't a number here, then it will be just a normal one. It won't have stretched or compressed. If there's a positive here, it's going to be a normal V like this. If it is a negative, it will have flipped over. It'll be upside down. Would call that a reflection over the x-axis. I'm fine with you saying upside down. Okay. And if it's a fraction, it will be a compression. I want to look at some examples of this. Yes, this is written down for you, but let's look at some examples. X minus 2 plus 5. Okay, well, the vertex, axis of symmetry, and the transformation. The vertex comes from here. Here's my H, here's my K. My vertex is 2, 5. You don't have to do any calculating for that. Your axis of symmetry is X equals 2. Describing the transformations means that it went right 2 and it went up 5. That's the same as what we had talked about before, okay? This one I'm adding just a little bit here. Here's another equation for you. Let's think about what happened. Our vertex is -1 minus a negative, -1, -3. Our axis of symmetry, once you have your vertex, your axis of symmetry is X equals -1. Over here, this is going to tell us something about stretch or compress. Think about it for a minute. This tells us we moved left 1. This tells us we moved down 3. This tells us that we compressed. We had a compression of a half. And this negative tells us that it reflected over the x-axis, or you could say it turned upside down. Left 1, down 3, reflects in the x-axis, compression of 1/2. That, my dear students, is that. Please work on your assignment. Make sure that it gets done by Monday. We do have to move it along next week to get our friends that are going on the tournament to take their test before they go away. The end of the quarter is looming large. So please, please, please make sure that you're doing your part, because we have to wrap it up and get everything taken care of. Yes, I am aware that PSATs are coming up next Tuesday, or not next Tuesday, but the Tuesday. I'm aware of when they are. Okay, so we can definitely work with that. I just need to get all my soccer players taken care of before they go on tournament. Okay? All right, bless you. Have an amazing weekend. Bye-bye.